The most distant human-made object ever created is NASA's legendary Voyager 1 spacecraft, a machine that has managed to accomplish what once seemed impossible, reaching the mysterious realm of interstellar space. Think about it. Imagine launching a spacecraft nearly half a century ago, long before smartphones, high-speed internet, or even modern computers, and yet today, it is still alive, still traveling, still whispering secrets of the universe back to us. That's not just science, it's a legacy. It's living history, redefining what it means to explore. But here's where the story becomes truly fascinating. This brave spacecraft is not just some distant relic drifting endlessly into the cosmic dark. It is still sending data to Earth across billions of miles, using technology so primitive that it makes a cassette player look futuristic. And here's the real twist: the spacecraft, launched way back in 1977, has made discoveries so profound that scientists all over the world are left stunned, their understanding of the universe forever changed. What did Voyager 1 really find out there in the frozen void? And more importantly, what could these discoveries mean for us, here on Earth? To understand the magnitude of Voyager's achievements, we need to travel back to a defining moment in human history. In the early 1970s, NASA engineers and visionaries were dreaming big, bigger than ever before. At the heart of this ambition was Gary Flandreau, a brilliant scientist at NASA's Jet Propulsion Laboratory. With nothing but a pencil, paper, and the determination to find a path through the stars, Flandreau discovered something extraordinary. By sheer luck of cosmic timing, the four giant planets, Jupiter, Saturn, Uranus, and Neptune, would be aligned in the late 1970s and early 1980s in a rare celestial pattern, a cosmic highway of sorts, linking the planets like stepping stones across the solar system. This was not just chance. This was opportunity. The alignment meant that a spacecraft could borrow gravity from each planet it passed, using their immense pull like an invisible sling, gaining speed and energy without burning fuel. With each swing around a planet, the spacecraft would be flung further and faster into the outer solar system, reducing what would normally take 30 long years to a mere 12. The only catch? This unique alignment of planets happens only once every 176 years. Miss it, and humanity would have to wait for nearly 2 more centuries to try again. NASA could not afford to hesitate. Within a narrow window, and with only 15 days separating their launches, 2 nearly identical spacecraft were sent on a journey unlike any before. Voyager 1 and Voyager 2. Few could have imagined that these twins, launched in the summer of 1977, would become humanity's greatest explorers. Their mission? Officially, just 4 years. But destiny had something else in mind. More than 45 years after those rockets roared to life, both Voyager spacecraft are still operational, still transmitting daily messages from the outermost edge of the solar system, breaking every record in the history of spaceflight. They were meant to be short-term scouts, but instead, they became pioneers rewriting our understanding of the universe. And oh, the surprises they revealed. Voyager's early images of Jupiter's moons stunned the world. Io, once thought to be a frozen rock, was revealed to have active volcanoes spewing fire into space. Europa showed evidence of vast icy oceans beneath its frozen shell, oceans that may even harbor life. Saturn, too, revealed its secrets through Voyager's lens. Rings more complex and alive than scientists ever imagined, moons with atmospheres, and landscapes carved by forces both alien and familiar. Voyager 2, in particular, became a trailblazer. It was the first and only spacecraft to visit Uranus in 1986 and Neptune in 1989. Entirely new worlds were revealed to humanity for the first time, mysterious, frozen giants, cloaked in clouds and storms. At over 14 billion kilometers from Earth, this tiny spacecraft, no bigger than a Volkswagen Beetle, continued to astonish. What was once thought of as a simple probe had transformed into a timeless explorer, stretching the boundaries of human knowledge into uncharted cosmic seas. And yet, despite its astonishing journey, the spacecraft itself was surprisingly humble. Each Voyager carried only 69 kilobytes of memory, less than what's needed to store a single photo on a modern smartphone. Their data was stored on magnetic tape recorders, then transmitted to Earth by a transmitter using just 23 watts of power, less than a household light bulb. To bridge the cosmic gulf, they were equipped with a massive 12-foot antenna to beam their signals home, using radio waves that traveled at light speed. But distance is relentless. Every single day, Voyager's signals take 3 to 4 extra seconds to reach us. Today, signals from Voyager 2, for instance, take more than 18 hours to arrive on Earth. Even more challenging, our planet has only grown noisier since the 1970s. The radio signals of humanity, television, cell phones, satellites, all fill the skies with interference, making it harder and harder to hear Voyager's faint whisper from the darkness. And yet, despite the odds, those whispers keep coming, carrying with them messages from the very edge of the unknown. Beyond the planets, beyond even Pluto, lies a mysterious and enigmatic frontier. The Oort cloud. A vast sphere of icy bodies that extends halfway to the nearest star. Voyager is not there yet. But it has already crossed into an even more mysterious realm, the space between stars. This transition happened when the spacecraft crossed the heliopause, the invisible boundary where the sun's influence fades and the interstellar medium begins. For decades, scientists debated where this boundary actually lay. Some estimated it at 50 astronomical units, others much further. So NASA decided to keep the Voyager mission alive, even as the spacecraft approached this milestone. When Voyager finally crossed into interstellar space on August 25, 2012, the data it sent back astonished everyone. Plasma densities around the spacecraft suddenly increased, confirming it had entered a new environment. Yet, strangely, the direction of the magnetic field barely changed. This was unexpected, almost unsettling. Crossing into a new realm dominated by the gravity and radiation of other stars should have shifted the orientation of magnetic forces. But it didn't. This single detail sent shockwaves through the scientific community. Were we wrong about interstellar space? Was the universe beyond our sun stranger than we dared to imagine? The Voyager spacecraft have turned into more than just machines. They are now messengers carrying golden records engraved with music, greetings, and symbols of Earth. Our attempt to say hello to any intelligent beings they might encounter. These spacecraft are, in a sense, time capsules of humanity, drifting endlessly, perhaps one day to be found by civilizations we cannot even imagine. And so, as they sail deeper into the dark ocean of space, farther than any human-made object has ever gone, they continue to challenge our imagination. They remind us that exploration is never about reaching an endpoint, but about expanding the horizon. The Voyagers were never supposed to last this long, and yet here they are, still exploring, still surprising us, still making history. And perhaps, most importantly, they remind us that even with the simplest tools, powered by the humblest technology, when human curiosity is paired with courage, there are no limits to how far we can go. So the next time you look up at the night sky and see the faint glimmer of distant stars, remember this. Somewhere out there, two small spacecraft built in the 1970s are still traveling, still carrying our story into the unknown. And with every passing second, they move a little further, taking a piece of humanity with them.